Welcome back, everybody. So I've been getting this question from a few of my students, so I thought I'd make another YouTube video. And basically, the question is surrounded by, you're given this graph of a function, and then you need to visually represent this difference quotient, or different components of the difference quotient. So let's take a look at a specific example. So we're given the graph of y equals f of x. That's this red line, or this red curve right here. And you may or may not be given that the distance h is this little distance right here. Sometimes you're not given that, and you just have to estimate it or create your own length. So for now, we'll say that's about this length right here. So it's almost the length of a tick mark on this square unit, or this unit square. So I'm going to do A through E, and we're going to use this little tick mark distance for H, which is an arbitrary positive distance. So the first thing to note is when we don't have an F in front, that's representing the X values. So X in this case is 2 plus H. So 2 plus H along the X axis is going to be 2, and then we go out this little distance H, and there's our 2 plus H right here on the x-axis. F of 2, so since we have an F, that's going to be our y value at 2. So our y value at 2 on the curve is right here at this height. So this is our sort of height F of 2. The F of 2 plus H is what is y when x is 2 plus h. So we need to go to the 2 plus h, go up until we get to our curve, and there is our f of 2 plus h height. So we've got so far 2 plus h is right here, and we have f of 2 is this distance up to the curve, this height, and then f of 2 plus h is this height from the x-axis to the curve. So now if we want to find part D, we want to find our y when we take this y, f of 2 plus h, minus, I'll call that part 2, minus this y. So we have, along this height, if I draw this horizontal line over, and so this is f of 2, this distance right here is equal to f of 2 plus h minus f of 2. And the way we see that is the entire distance is f of 2 plus h. And then if we want to subtract out this area, this length, that's f of 2. That's what we get remaining is this distance right here. And then this distance is going to be my change in x's, which is, this is my 2 plus h over here, and this is my 2. So I'm going to subtract 2 plus h minus 2, which is equal to h. I could simplify that. And that's this length right here. So now for part E, which is really the main goal, we want to find out how to interpret this and how to label it on this graph. It looks like a really complicated expression. It's called a difference quotient, but it helps if we remember that the f expressions are a y value, so we'll call that y2, and this is also y, but we'll call that y1 since it's a different y value, and then this is an x because there's no f in front of it, call that x2, and this is also an x, and that's x1. So what we have here is basically an expression which looks like it's in the form y2 minus y1 over x2 minus x1. And this is in general the formula for the slope of a line passing through 2 points, namely x1, y1, and x2, y2. Now, in particular, we know that x1 is equal to 2. We've already established that here. And x2 is equal to 2 plus h. And we have y1 is this value, f of 2. And y2 is equal to f of 2 plus h, right here. So if we want to label what this is basically the slope of the line passing through the x1, y1, which is 2 comma f of 2. That's our x1, y1. And x2, y2, which is 2 plus h and f of 2 plus h. That's our x2, y2. And so here is our x1, y1 right here. And this is our x2, y2. And if we connect those two, we'll get a line. And the slope equals what we have in part E. So this is the basic solution process for this particular example. In general, I just wanted to summarize before I closed off here why this is important and why you might be seeing this. In the very near future, this difference quotient is going to pop up in what's called a derivative, or the definition of a derivative. And that has many very significant applications and results in calculus. In fact, pretty much the first big chunk of calculus is based completely on derivatives. And so this is sort of like a very early foundational piece about derivatives. I hope this helped. If you've got any questions, feel free to ask. And if you enjoyed this video, please like it and subscribe so you get notices for new videos. Thanks again.